The Center for Innovative Materials Research at Lawrence Technological University in Southfield, Michigan, conducts tests to find ways to keep that from happening. Inside this 18 by 8-foot chamber, structural materials are put on the hot seat to see how long they can withstand intense fire.
If you remember what happened in 9/11, the building itself did not fail because of the impact force. It failed because of the fire.
The purpose of the furnace is to simulate a fire environment, similar to what might happen on a building fire or a fire on a turnpike.
9 3,000-degree Fahrenheit flames heat the chamber to its 2,300-degree maximum temperature.
You need air or oxygen. You need a fuel, which is the natural gas in this case, and you also need a source of ignition. With those three ingredients, you can have combustion.
What really makes this chamber unique is the fact that it can heat a 32,000-pound load to 1,000 degrees in 5 minutes.
Thousands of times more heat required than a home. The typical home furnace may operate with 100,000 BTUs an hour, where this furnace operates with 18 million BTUs an hour.
It also operates at much higher temperatures, requiring 12-inch thick insulation around the entire furnace. The center allowed the chamber's enormous door to open during testing, to give modern marbles a rare opportunity to look inside.
We intentionally have the furnace on very negative pressure right now, so it's drawing a lot of room air in to keep the area around here cooler. Otherwise, we might burn up some of the cameramen and myself in particular.
The door closes again, putting the pressure and the heat back on the concrete beam. While conventional concrete beams have steel rebar inside, this beam has been reinforced with carbon fibers instead. These fibers, developed at the center, are stronger and less corrosive than steel, but are also more flammable. After about 20 minutes of full heating, the concrete has crumbled and the fibers are singed.
So we need to make sure that the next step in our research is to identify new materials that we can spray on the top of the concrete beams to prevent the heat from reaching carbon fiber. Certainly the structure will last for a longer period for corrosion and fire.
That could also mean increasing fire evacuation times from 1 or 2 hours to at least 5 or 6 hours.
When you have more time to evacuate people, you can save a lot of lives.
While thousands of degrees cause destruction in this chamber,